homework, you're starting to see it's starting to become repetitive, because what I'm starting to do is give you some problems that, hold on, going all the way up here. Right here, day 4. You've done this before, I promise you. Because if you took physical science, that is. If you've taken physical science at all, you've done Half-Life. You might have done it a little bit differently because science makes things a little bit more complicated, but math people like to make things easier for you. At least that's my opinion. Yes, the nurse, I forgot. Sorry.
I got this song stuck in my head.
What song? Is it appropriate?
Yeah. Ba-da-ba-ba-ba. I'm loving it.
Did you go to McDonald's recently?
Yeah, yesterday.
Was it good?
I got a Shamrock Shake.
Okay, I need to get one of those for sure.
You never got one yet?
I mean, not yet, not this year.
Ba-da-ba-ba-ba. I'm loving it.
Mom, prescribe me a pain pill.
Oh man, I got 2 pieces left.
You will need a doctor, the nurse can prescribe you.
I'm out. I started
You would have to have your own painkillers, and you would bring it to school, and they would administer them to you. That's how school works. You can't just be given.
You want the box?
Yeah, like that's not how it works. Yeah, schools are that's not even like our law. That's like a state thing. Yeah. Okay, so Half-Life. Back to Half-Life. Like I said, you've done it before. You did it when you were in physical science. It's talking about, okay, so again, just random stuff here. Drugs, any kind of drug. It has a half-life. If you go on Google, you type in the half-life of caffeine or alcohol or marijuana, anything. There's a half-life of every drug, okay? And you can find out how long it's going to be in your system for using this formula, okay? So, how much do you start with? How much do you take? And how much are you left with? This is very important when it comes to nursing, if you were ever to become a nurse or a doctor or anything in the medical field, because if someone comes into you in the emergency room and they're on something, you can't give them other drugs that might help them because they're hurt, maybe, because it might counteract with the thing that they're on. Okay, does that make sense? So you have to understand the idea of how something leaves your body, and everything has a half-life, and that's kind of what we're talking about today. So, and you've talked about it a little bit in science, but we're going to talk about it a little bit more now in math. So Simon is studying for half-life. The amount of time it takes a substance to decay half its original life, pretty straightforward, okay? So it takes 5 days to get half of that out of your body. Some drugs are longer than others, just the way it works. It's not always just drugs, it could be something else. But mostly that's what it is. I mean, caffeine is a drug. That's just what it's labeled as. So Simon is studying for a big test and is trying to stay awake. He drank a 12-ounce can of Big Buzz, which is not a real drink, I don't think.
Mountain Dew, probably.
Well, Mountain Dew is really high. I looked it up the other day.
I have one every day at lunch.
Okay, so let's just go through the problem. That contains 80 milligrams of caffeine. That's what I'm starting with. When I drink the drink, I start with 80. Okay, our phones are away. He is wondering how long the caffeine will stay in his system if he has a half-life of 5 hours. Okay, so, hold on. How much caffeine remains in Simon's system after 5 hours? So if I start with 80 and the half-life has gone by, now how much do we start with? 40, because I'm, again, dividing by 2, which gets me 40. So I have 40 milligrams still left in my body. Because you're doing half-life, I'm decaying by a half. Now, what about after 10 hours? 20, because again, I'm going to be dividing by 2 one more time. Okay, that you can keep doing it that way, and that's the way you learned it in science, but we will be learning a general formula that's going to help us in anything, yes.
How does that work? How does it decrease less?
It's decaying. It's
time.
not decreasing, it's decaying from your body. So the longer, so you know how everybody says, like, you'll heal in time, because time takes things out of your body. It like if you are on something when you go to, okay, so like if you guys, okay, I have ADHD and I take medication for it. Okay, I'm the first one to tell you that. And by the time I get home, it's half out of my body at least. Okay, that's just the way it works. That's why you don't feel it towards the end of the day. If you're on any medication, it comes out of your body. That's how it works.
Like, why does it slow down? Why does the
It doesn't slow down, it starts coming out. So like you go to the bathroom, it starts coming out of your body. It's just the rate that like your body, so like you have these fluids in your body that start to just like decay it.
To be honest, it does remind me of a paradox in a way.
I'm not even sure what a paradox is, to be honest with you.
Ba-da-ba-ba-ba.
No, I'm just like not good with words. So, what is the initial amount of your caffeine? So, how much did he take in the beginning? 80 milligrams. I just wanted to make sure that you understood that that's what's called the initial amount. You start there. At what rate is the caffeine decreasing at a system? A rate is something like a percentage or a decimal or a fraction. What it would be 50%, or it would be 0.5, yes. Or it would be 1/2. Okay, it's decreasing every 5 hours by a half. That's called the rate. So every 5 hours, it decays by a half. So this is your general formula. Last year when you were in physical science, if you took it, you did not have this H value. You did not have the T value. No, you didn't have the H value. Okay, we're now introducing this formula to you. We're taking it one step further from last year, and we're able to now put in, let's just say I want to know 3 hours. In 3 hours, how much is still in my body? Am I still getting what I need? You can find that out now with this formula. So this A sub 0, a lot of people get confused on what the 0 is. It just means like, where are you starting? Because you start at 0. I didn't take anything yet, and then I took something. This is just like a representation of where you're starting. Yeah. And then the T is time, and the H is your half-life. So write an exponential function to represent the amount of caffeine remaining in your system, in Simon's system, after the amount of time has passed. So all we're doing is plugging in the information that we just wrote down into this formula and leaving T alone, right? Okay, so I have A equals, what was the initial amount that Simon started with? 80. The 1/2 is automatic because it's a half-life. It's part of the formula. I get questioned on it all the time. It's just part of your formula because it's a half-life. How much time? We don't know. We want to create a function that I can put in anything in the world, anytime, 10 hours, 20 hours, and figure it out. But what was our half-life?
40.
Ooh.
20.
Well, it was, okay, yes and yes. Okay, so we went down, we got to 40, then went to 20, but it was after 5 hours. So 5 is going to be our half-life. It took caffeine 5 hours to decay by a half. And that's our formula now. So now you create a formula, and you can plug in any number to find out how much is still in your body. So let's plug in and see how much it remains in Simon's system after 2 hours. So I'm going to plug in 2. I have my 1/2. And now all I'm doing is I'm plugging in T, which is 2, divided by 5. Questions on what I did there? All I did was plug in 2, because you might need a calculator, because unless you're really good with fractional exponents, okay, it's going to be kind of challenging. So you'll have to type this in your calculator. Let me know what you get. 80, I can even help you out by putting it. If you don't have one, go grab one, because you're going to need it today. You're going to need it the rest of the year, so you might as well just get grab one when you walk in. Put your IDs up, please, if you do grab one. I do have time after school today, so if you do need help with anything, I will be here until 4 o'clock. Then I have to go to softball, and then I'll be grading your test because I've been so behind on that with softball. So again, thank you for being flexible with that. All right, let's type this in. I have 80. We'll find out. I don't use keys, so I don't know off the top of my head. I have to try it. So I have 80. You can do 1 divided by 2. Or you can do 0.5. They're the same thing. So some people like hate fractions and just do 0.5. That's fine. Caret. Come on. And then I had, what was it? 2 divided by 5.
Aren't you supposed to put parentheses?
You can put parentheses. So if you have an older calculator, you put parentheses around your graph. If you did not get 60, that might be why you did not get 60. So do it one more time about parentheses right here instead, because that could be why you're not getting it.
What do we do?
60.63?
Yeah, so 60.63 milligrams is still left in his body after 2 hours, because 2 hours is not a lot of time, so that kind of makes sense of why it would only be 60.23. Did you get it now? Did you get it now? Okay, cool. Suppose that Simon is taking an antibiotic. So I will give you like a health lesson here, because I taught health for 1 year, way back when I was at Lincoln Way East. Okay, so antibiotics tend to mess with certain medication that you're taking. And that's why it tells you not to obviously drink when you're on antibiotics, because it could be defective. So antibiotics do things to certain medication, not all of them, but certain of them. So I'll talk about one thing. There's only one female in here. But if you are ever on birth control, or your girlfriend or your wife or whoever it is on birth control and they're taking antibiotics, it's gone. You no longer have birth control. That's how it works. Okay, because that's what antibiotics do to certain drugs. It made it defective. So if you, again, in the future, just have that in your head. Okay, if your girlfriend or you personally are on any kind of birth control and you take antibiotics, it defects it. It's gone. You no longer have birth control because the antibiotic is killing it. Okay, that's kind of how it works, and that's why we're going to talk about it here. Good question?
When it says that an antibiotic extends the half-life of caffeine, wait, is it like after an hour that he drank it?
It's just saying that, like, because he's taking antibiotics, he's no longer 5 hours decay. It's going to take longer. It's going to take 8 hours to decay. So now our half-life is no longer 5, it's now 8. So that's all it's saying, is that now we're changing the half-life to 8 because, like I was saying, that antibiotics tend to do that to certain medications. Hey, how are you? Okay, so again, half-lives can extend. It could make it worse or it can make it defective. It's gone. So write a function B of t that models the amount of caffeine under the new condition. So same exact formula, but instead of 5, what am I going to have? 8. So I'm going to have B of t, because it's what it's asking for. That's why I'm getting B of t, is equal to 80, 1/2, but it wants the t to stay in there and put the 8. So again, we're just creating a formula. So now that we know how much is going to be in our body after we have taken antibiotics and drank caffeine. Okay, so it's crazy how that works, and that's why medical people get paid the big bucks, because they have to do things like this. Obviously, they have computers now that do that for them, but they have to understand it. Yeah. They do, and sometimes I've witnessed, because my mom, like I told you in the past, you know, she had cancer and she had chemo. I've seen them do calculations very quickly to figure out how much she can take because of her body weight and blah, blah, blah. Okay, so these things are really cool to understand. I mean, even if you get sick or if anyone else you get sick, or you're understanding that how drugs work. Yes.
So like anesthesiologists,
They do the calculation. Yeah, they do this all the time. Yes. It's a lot based off your body weight. Half-life, yeah. Especially because, yeah, it's crazy. I actually, the one para that was in here, she was blonde. She subbed in for Miss Miller one time. She was in here like 2 times. She's becoming a nurse, and she was asking me questions on the math before. It's really cool how that works out. Anywho, compare the 2 functions. We're going to look at both of them. What happens when you take an antibiotic and when you do not take an antibiotic? What happens? How much is still going to be in your body? So we're going to look here, and we're going to talk about this. So how many hours have passed? That's what this is. Okay? And as you see, our half-life is 5, so it's going by 5s here. So here, how many did we start with in the very beginning with no? Yeah, I started with 80, and then what did we go to?
40.
And then? Okay, so here you can see it took 20 hours. That's a lot of time. That's almost a full day. And there's still 5 milligrams of caffeine in your system. So when you drink Mountain Dew or Red Bull or whatever it is, that's why you're so energized,
So, like,
and it's so bad for you.
when you do those like power shots, Starbucks thingies,
Espresso?
They're not as bad as energy drinks. Like, coffee's different. Coffee's like in the 40s if you're going to do an espresso. But when it comes to energy drinks, like, that's why people's hearts you ever hear about people's hearts getting bigger and larger due to drinking too many energy drinks? Well, it's true. So be careful if you drink a lot of energy drinks, because people have health issues. Lots of health issues when it comes.
You
Like,
see the video where like this guy drank 20 Red Bulls in one day and his heart was like right
Yeah,
here?
yeah.
It was all red. It was like
yeah. Well,
Yeah, that's pretty scary.
there's no joke. It should be banned. I mean,
heart rate.
it's not good for you at all.
now that I know this, like my friends get the big monster.
Just don't do it. It's, again, in moderation. You drink one once in a while, fine, not a big deal.
Mountain Dew's
But if you
better.
do it every day, that's an issue. So
Is it the same energy like the low?
you have to look at the caffeine. So on the sticker, it'll say caffeine is this amount of, yeah. Okay, so how many half-lives have gone by? So 0 half-lives have gone by. 1 half-life has gone by.
2.
Then 2, then 3, then 4. Okay, these are just the half-lives. All you're really doing is you're doing 5 divided by 0, 5 divided by 1, 5 divided, wrong way. 0 divided by 5, 10, 5 divided by 5, 10 divided by 5. You're taking the half-life and you're dividing it by how many hours are going into it. So let's talk about this one though, because this one's different. We're still going by the same time, but our half-life's different. This is where it gets complicated when in terms of half-life. So obviously we're starting at the same amount. We both start out at 80. So with your calculator, I'm going to need some help because I don't have decimals in my head. I need to take the half-life of, or how many hours have gone by, which is 5, and divide it by the half-life. How many half-lives have gone by?
Wait, so it's 40 divided by 8?
Well, all I want to do is 5 divided by 8. What is it?
0.625.
So 0.625, something like that. Here I'm going to take the number of hours and divide it by your half-life. So I'm going to do number of hours divided by half-life. This is how you find out how many half-lives have gone by. Because we're not going by 8s. We'd have to go by 8s to divide by 2 every time. That's the only way. So then, what is 10 divided by 2? Point. 10 divided by 2? Anyone?
10 divided by 2? Would that make 5?
What'd you say?
1.25.
Whoa. It can't be 1. Is it 1 point? Yeah, 1.25? Okay. What is 15 divided by 8? We'll go with 1.8. What's 20 divided by 8? Perfect. Okay, so this just means that, again, it takes 8 hours with amoxicillin. Now we're in amoxicillin. We have to figure out how much is left in your body. But now it only takes 8 hours, so we're not going to be able to divide by 2 every time because we're not in perfect half-lives. So we just have to plug it in. So let's plug this in. I'm just going to use the side just for some work. I'm going to plug in 5, 80. Again, if you like 0.5 better than you like 1/2, then use it. I'm going to plug in that 5 because I want to know how much is left in my system after 5 hours, and I'm going to divide it by 8. So plug this.
So it's not that 1/2.
Yeah, we can't divide by 2 because we're not in the perfect half-life scenario here. If I was going by 5s, or if I was going by 8s in this situation, I'd be good. But I'm not. So I just have to plug it in. What do you guys get when you plug it in?
51.8.
51.87.
If you did not get 51.87, it's probably because in your calculator in green, make sure you're using parentheses here. Whenever you have a fraction, I would use parentheses.
Wait, what fraction is it?
51.8 something. And let's just think about this in logic terms for a second. If I decay by a half here, think about it. It's not a full half, is it? Actually, what is it? It's more than a half. So I decayed more than a half here. So I should be more than that 40. I should be. So let's talk about this next one in 10 hours. Go ahead and fill in the rest of the chart. See if you can plug all these in. 80.5. We're plugging in 10 now instead. So all I'm doing is I'm plugging in these numbers into my formula. That's all I'm doing. See if you can fill in the rest of the blanks, please. We're almost done. We'll only do one more.
I got 598
So
for the
for 10,
8, 5, 10, 8. For no, yeah. 10, 8.
okay, so 0.5.
Yeah, it's 0.5.
Yeah, it's 0.5.
So it's 80. I already
Are you getting to me?
So you could.
What? I was trying to see.
Oh, you're
Yeah,
sorry.
I got them all.
Wait, is it 80 divided by?
Remember, this is 0.5, sorry, or it's 1/2. You could use 1/2. You can use this instead.
33.6.
33.6. What'd you get for 15?
21.81
Your mom. Okay.
and 14.4.
I guess I'm not.
21 point what?
21.81.
Okay, so that's how much is left. So some of you are not trying that out. When you ask me on the test how to put it in the calculator, I'm not going to respond. This is what kills me. Okay, last one here because I'm only going to do one more. I don't really care about this one. I will talk about I. What generalization can you make about the effect of a larger, smaller half-life? So think about this really quick. We compare the two. If I have a smaller half-life versus a bigger half-life, I had 5 hours it took, and it took 8 hours here. What kind of generalization can you say about the half-lives?
Maybe less.
Bigger, bigger half-life means more decimals.
Well,
Okay,
bigger half-life means it's going to be less in your system.
kind of.
Well, actually,
So what kind of generalization can you tell me about the number of half-lives you have if it's bigger or smaller? Yes.
When it's smaller, the half-lives are bigger.
When it's smaller, the half-lives are bigger. So like when the number...
bigger half-life does a bigger, more amount.
Okay, let me rephrase it. So you're kind of right. Let me rephrase it. So am I decaying faster or slower when I have... I'm decaying a lot... What?
Slower.
So top when you're decaying faster and the bottom when you're decaying slower.
Yeah.
Good. Okay, so listen to that. Well, think about it.
When you're going from 80 to 40 to 20 to
Yes.
25.
Do you look at the decimals to see what's anything?
When you look at the okay, so let's talk about this for a second. Hold on, relax. Relax, everyone. Relax. Okay, think about it. On the top, 5 hours has gone by. 40 milligrams is what's left in my body. On the bottom, I took amoxicillin. 51 milligrams is left in my body. So it's decaying what? Slower or faster if I take amoxicillin? Slower. So the larger the half-life, the longer it takes to decay. That's all I was trying to get at. So sorry for confusing you. But if you look at after 5 hours, when I took amoxicillin, it took longer. I still had 51, whereas I had 40 in my other situation. All right, let me give you the homework.